Good.
These mic stands get depressed.
Yeah, I heard about that. Okay. All right, very good. All right. Okay. All right, well, my name is Jan Samborski. Welcome to the Training Your Inner Cowboy, bridging from programmer to developer. The line I wanted to start out with was, I know I'm not the smartest in the room, but I sure hope I'm not the dumbest. I guess we're going to find out right now, so let's go in. This presentation is going to be for the beginner or seasoned developer or programmer. It's mainly for people who use Perl Moose. How many people here use Moose on a regular basis? All right. It's also more for the solo or small team programmer. I'm a system admin. I typically do my own scripts and my own applications on my own. So it's good for people like me, hence where the cowboy term comes in. And I found over the years that you need to go back into code and make changes. So I've developed a system, which is the what I put together from what I've learned and from what I've seen, and basically call it Rapid Apps, a grassroots development system which gets you from idea to app in a fast, reliable, and predictable workflow for a wide variety of applications. For me, it's mainly CLI, but this would work with databases, websites, what have you. Maybe not so much websites, but anything that you're using CLI for, command line interface. Rapid Apps is using many of the agile techniques and practices that we'll discuss as we go through this. Many of these practices are adopted by, I'm sure everybody here has heard of Agile, and probably a lot of people here are using it. I've cherry picked. I'm only using the best of what I find that works for me. Why am I doing this? I believe this system is simple enough to teach newbies to code and develop apps quickly to reinforce their learning. Not a lot of syntax. There's code is at the very back quarter of the of this workflow that's put together. So from that, there's not a lot of stuff for them to remember. And hopefully, we'll talk at the end about this if you agree with that. Also, with experienced developers, you're on the other end of the scale. You're juggling many different applications, and for you to go from one app to the other takes some spin-up time and all that type of thing. Anything that we could use that will help that is going to be beneficial. Ooh. Okay, so again, when I first put this presentation together, it was almost 2 hours. I've trimmed a lot of it back, but I'm going to try to go as quick as I can. So if there's questions, please hold until the end, and we'll talk about them then. All right, so the process. You have an idea. You come up with a short, precise name for what this is going to be. The process, the application that we're going to talk about during this demo is CSV Manager, where we're in a department. We have a lot of people who use CSV files. They want to be able to slice and dice that data without having to push it into databases, without having to push it through any kind of external tools. So on the command line, they want to be able to pull column names. They want to be able to sort by certain things. It's not the best solution that's out there, but it's a good example of how we would use this. So for the sake of this first process, we're calling it CSV Manager, and you're going to see that a lot. So define your app from the user's point of view with user stories. This is one of the big things of Agile, where it's from the user's perspective, and we'll certainly get into that. The next part of this is we set up the wrapper. And the wrapper script is basically we come up with conditions, CLI parameters that we're going to use as a first pass, this is all very iterative, so your first pass is going to be just to get the parameters in and verify that it works. It doesn't do a lot, and we'll get into the details of that. Then, of course, the next big step is creating a test-driven environment, TDD, to begin your app development. And this, quite frankly, is where you're going to spend 90% of your time with your application. And then you deploy your app to production. This is where I was coming from with a lot of the Git questions from earlier, because right now it's brute force. I just pop them into a zip file. And then the last step I'm having a little bit of problem with. I haven't completed that one yet, but make $1 million and live happily ever after. Okay, so rapid apps, the parts. Perl, of course. Any modern version of Perl works fine with Windows, works fine with Linux. I assume it's going to work fine with Mac. The modules that we're using, Moose, of course. Because of the iterative nature of this thing, you're constantly flipping back and forth, going through. You'll easily do a dozen changes in a minute. I don't know if a Moose still has that 3-second delay that's up there. I've been using Mouse for so long. I've yet to see a problem, and I've used a lot of complicated examples in my coding with delegation, with roles, with most of the real world stuff. I'm sure that there's stuff it blows up on, but I haven't come across it yet. Unit testing, we're going to be using test class for that. And of course, for all the testing, we use the bundle of all the test methods, which is test most. I use Vim, which is going to have just a little bit of custom macro settings. I use a lot of the split windows and that type of thing. And then it's provided as open source. I use a spreadsheet for the user stories. I wanted to keep this open source, so I tried OpenOffice Calc for the first time about a week ago. I was impressed. It certainly worked plug-in compatible for Excel, and for what we're using it for, yeah, it was no problem. Okay, so jumping right into this with user stories. What is a user story? A user story is a very short description, a synopsis of how a user would use your app and why. It's typically just a one-liner where it has a template. So as a user, I want to do something so that I can, continue my job, so that I can import this into some other application, so on and so on. We'll certainly get into details on that. We leave out all the technical details that are on there. In fact, it's more of a promise of a conversation that you're going to be discussing this with the user who's on this. We're also doing an end-to-end slice. Well, one of the books that I've going through was the Agile Samurai, and what they have a perfect example of that, where if you had a cake, like a Black Forest cake with an icing and then a cake layer, then a jam layer, and all these different layers that are going through, we're cutting right from the top right down to the bottom. So we give a very thin slice to the user. Doesn't have bare bones, air protection, all the bells and whistles aren't there. It's just something that's very minimal. As opposed to a waterfall where you would take that slice and go across the top, and then you take another slice going across the top. Not very useful, but that's how things were basically. If you go to Google on user stories, you're going to come across this mnemonic, the INVEST mnemonic. This is what defines a good user story. User story is independent, so we can have user stories that vary from one portion to another, and they stand on their own. You don't need to have other ones to make that. Negotiable, they're less detailed, gives more wiggle room when the going gets tough. So if during the development on this you find that there's a problem, you can negotiate what that user story is going to be as long as it has the same outcome. Valuable. We as programmers, we often think that we know what's better for the user, so we're going to design what's there, and the client says, well, that's nice, but this is taking it the other way around. It has to be value to the user, and the user says, well, I'm going to use this so that I can import into my other spreadsheet. I can import into this database, so on and so on. Estimatable, there has to be enough details in there so that you can actually say that, okay, it's going to take so much time. We're not looking at nailing down the time yet, but you have to have details. I want to have a website that's as good as Amazon, not enough details. So And of course, and that leads into the next one, you want to keep it small. Certainly easier to manage a small piece than a big piece. And of course, we can mix and match when they're small pieces. And testable. And the user story is done if a set of unit tests, or even just a simple unit test, confirm if the functions, what functions the way it should. So when we run the unit test against this, and you're going to see this right, I think now. Yeah, okay. Is that, can people see that in the back at all? No? All right. Well, oh geez, control. Yeah, okay. So what we've got, is that better? Yeah. Okay. So what we've got here is that, now I have the descriptions at the bottom, so we'll just have to go, this is obviously the spreadsheet part that's going to be in here. We have the very first case, which from a user point of view, I want to be able to select columns based on a regex. So let's say we have an example here of the CSV, which is going to have the columns last name, first name, and age. Right? So we kind of going back and forth here, but as a UXA, I want a Unix administrator. It could be anything. It could be a marketing rep. Typically, this is a general user actor. We want to select columns based on a regex so that I can work with my desired subset of records. And we go through these kind of examples that are here, right? You have all these different user stories. And I'm going to get into what these yellow columns are shortly, but what I mentioned with the unit test, we use this kind of pseudocode, this given, when, then. I've seen it described as BDD, behavior-driven design. It's pseudocode for unit testing, where that basically you have a valid CSV file. So now you're going to have some kind of a method or some kind of object which is going to validate a CSV file. It's got a header, it's got the right number of columns, typical CSV stuff. When I run the CSV manager with these particular parameters, then I'm going to get this output. And that's right there. If that test works, that test is done. We can now manage that and go on to the next one, or whichever ones we deem the sequence is going to be required, which leads us into these points here, where there's priority. I'm just going to go down the bottom here. Yeah, okay. So you see here, we've got that one-word camel case label. I still go with the camel case because the snake case is going to come in later on when we're doing unit tests and conditions and things along those lines. The relative release is the next column. When we're releasing something, I think I got to it earlier about we're releasing a core set of value to the client, where that it's a walking skeleton, where that there's just a core set of values that are there. If we've defined that, that's our release 00. Something where that now we take that CSV manager and we make a whole report manager script out of it and have all these bells and whistles. Make that a 90, make that something that's way off in the end. We'll get to it, but we just don't want to forget about it. And then we get into these other points here, the story points. Story points are an agile way of comparing. The whole point of estimating is that even with experience, we don't have that ability to make very good estimates. But we do have the ability to make comparisons one user story against another. So we can basically say that this user story is going to take twice as long as that one, or that one's going to be 5 times as long. And you measure that by saying that if a one is really easy and something else is considerably more, it's going to be a 3, it's going to be a 5. We use Fibonacci numbers, which seems to be, there's a lot of theory behind that, but it makes a lot of sense. It's hard to determine the difference between a 5 and a 6, but it's generally easier to determine the difference between a 5 and an 8, or an 8 and a 13. And we're giving it just a relative scale. Doesn't mean anything, doesn't mean that how long it's going to take. Where it does get into how long it takes is this next column, which is the POM estimate. I get into time boxing on here. Pomodoros, how many people here use Pomodoros? How many people, okay, good. How many people are at least familiar with Pomodoros? Okay, I'm going to get into that on the next slide, but here you're going to put some kind of an estimate on that. And that estimate's important because it's like a contract with yourself or your team that's going to basically say that, yeah, I think we can do this in 4 half-hour increments or 6 half-hour increments. And of course, we're going to get to that right here. All right, so before I get into this, are there any questions on the user stories? I mean, I know if you're not familiar with them, it can be confusing, busy work. Okay, good. So this a general brief history on POMs, the time building blocks of your projects. Short Pomodoros, they are basically a 30-minute block of time. We take 25 minutes of work and then 5 minutes for each break. Sounds gimmicky, but it works. And when you're working within a POM, that's all you're doing. You got a label to it. You're working just on that part, which means you're not taking phone calls. You're not having any conversations, anything like that. When they do happen, you try to basically get that person to say, look, can I call you back in like 10 minutes, 15 minutes? And of course, when you get your break time after the timer's gone off, that's when you do that. The point of all that is that it's deep focus. A lot of the stuff that we're doing is it's complicated. It takes you a while to spin up, to get into that groove, to know what all the moving parts are, and then for you to be disrupted in any which way, it's counterproductive. So some people, 25 minutes may be too long, and for other people, 50 minutes might be the way to go. Whatever you do, if you're starting a project, keep those units of time the same so that you go through the whole project that way. Pomodoro system is that every 4th POM you take a 20-minute break. I have a hard time with that myself. I mean, the timer I'm using is an old one called Pomodoro. It's great, it follows the rules really well, but you never really know when that 20-minute break is coming up until you're actually in the middle of it, which would be better if you could move it around some. But yes, and you want to have an estimate to the POM before you start working on it. Again, there's no point putting an estimate when you're halfway through, because the more you estimate, it's like any skill, the more you do it, the better you're going to get at it. You're going to find the first couple of times it's going to be a wild-ass guess that you're going to, it's going to be low, typically low. It's often, not very often, it's high. And you got this whole thing here about the 8-hour day. Well, I'm good at math, so that's 16 POMs. Well, you'll have a hard time getting anywhere near 10. At least I do. People I've talked to have done that. You're going to have meetings. You're going to have other things coming up. If you can do 10 and you can do over 10 in a sustained pace, I want to shake your hand, because that's a lot. You'll get a lot done. And the only problem is that if you keep going at that rate, well, I don't know. I would think you're going to burn out, but if you don't, well, more power to you. And of course, after you do this for a week or two, you're going to get better at the estimating. All right, so the next step on all this is where I was talking before with that process chart, was your wrappers. And the wrappers, they don't do any heavy lifting. They just do all the organizing, they do all the prep work. So they're going to collect your parameters that you're passing from the command line, a JSON file, whatever your application is that's going through. And when it's do that, you can set your default parameters through that. They all group this into a hash ref, which I call rhconfig. This is what's going to get sent to your main object. It shows a comprehensive usage screen. So when there's an error, I'll get to that in the next step, but it also does the one other big thing where it takes that top object, I call it O-work in this example, and runs the holy trinity set of control methods, which literally is just a setup, main, and teardown. People are familiar with any kind of unit testing, that's where that's coming from. And that's all it does, is it runs from in an eval loop, so it runs through that process, and any kind of die that comes up, it'll get perked back up through here, and there's an A fail map where I take the expression, whatever that expression was of the fail, and then that gets mapped to an exit code. Further, when that exit code, when it's found a match on it, it'll show what the message is, display the show usage, and then exit with that return code. So if you're piping into other scripts, again, there's a UXA flavor to this, you'll get those kind of messages coming up. You can also have many wrappers for a project. CSV Manager, we've only got the one, but if you're doing something like we were doing with migrating a bunch of physical machines to VMs, you're going to have a particular sequence that things have to be done. All that sequence has to be asynchronous. So we put what you want, and you want that code base to stay the same. So there would be a 10 underscore init SSH keys, a 20 underscore copy Oracle binaries, so on and so on. And that would go through. Each one of them are going to have different parameters, and each one of them are going to have a different front end, but all of them are going to have the same code base. So what does this look like from the actual code? I go through, you open up Vim, you run this macro, the p start here macro, and when it runs, you basically got these 3 lines that are here. You're going to change your package here to whatever your project name is, in this case CSV Manager. You take each line, cut it, paste it, and run it in the Vim command line. And I've gone through different examples on this. I'd like to work with somebody who's good at Vim macros on this, maybe to improve this. But because there's a hybrid environment with me, I do all the development on Windows, and then I do all the back-end stuff on Linux, and typically with VMs. So it gets kind of goofy with the code being between those 2 environments. So at this point, this works. And of course, after you run that first line, you're going to see package template is going to be replaced with CSV Manager. I've defined where I've done a Samba mount off to one of my VMs, and it now has this tools proj packaged CSV Manager directory. So then here's the setup. When that's run, in this case there's going to be a CSV Manager PL sitting in the root of that CSV Manager directory. We open it up, and then we see the C show usage, and this is default. This is basically boilerplate that's coming through. RH data, so we can define our default parameters. We can define whatever our get op long command line options are, so normal standard stuff that's here. Whatever our required parameters are, so if somebody didn't put the CSV file in, it's going to fail. And then we have this A fail map. So, and all it is basically going to be an AREF, an AOA with basically the messages going in, an array of the regex expression, and then whatever the exit code is. And then we got some overhead that's on the end of that. So here, again, can you guys see this? All right, well, at this point here, I've basically gone through, I filled it out where that we have what an example of what all the parameters are. Your typical show usage screen that would be up. When it fails, it's going to show this. Before it shows this message, it's going to show what the error was that the die failed on, and then it shows this message coming up. In this example here, RH data, I've set defaults. So my debug is 0. I set a log file up. I've set a bunch of different command lines that are up. I've set the required parameters to say that if there's no cond for a condition or there's no CSV file, it's going to fail. And it'll fail on that first message that's there. It'll be missing a required with only one U, but your mileage may vary. Can't read a conf file, so a whole bunch of messages. So right at the very beginning, you're now starting to think on how, what's going to cause this thing to blow up. And as you're writing the code, you're going to want to now go back and forth to what these fail messages are. And then the overhead. Okay, so any questions at this point? Okay, good. Now we get into the meat. Where's the beef? Rapid apps and TDD, test-driven development. In a nutshell, it's basically write the test first, and when you run the test, of course it's going to fail because the method isn't there or the code isn't there to back it up. So then you write the code just so that it's going to pass just that thing. You don't throw a lot of features in. You keep it real simple. And the third step is that you refactor, and then you throw a little bit more. I mean, it's not unusual to actually put static code in there at the end. In fact, in this example, we'll do that. As you use this a little more, you'll certainly get the feel for it. Yeah, just very basic code that's there. And that's what I was saying before, when you do your iterations, you're going to do a half a dozen to a dozen very, very quickly inside of a minute. The test environment is completely contained and isolated from everything. There's no directory calls, there's no web calls, there's no database calls, no nothing. And by that, if you've got to read a directory, if you've got to read a file, do a TAC-R, or you've got to make a web call or anything like that, you make those accesses through mocks. What are mocks, you ask? A mock is simply a fake return. All calls to a method are replaced with this fake return. So I'll get into the example down at the bottom here. Big thing that you want here is, I don't know if anybody's gone through old school method, print, XYZ, if debug is equal to 0 or debug is, we don't want to touch our code. We do that separation of code and testing. We do our separation of code and whatever the mocks are at the same point. You can and should have several mocks for each method to test, varying inputs and conditions. You're going to have a mock to say, okay, if all the stars align and your file is good and everything works well, you're going to have this return. If it fails, like you can't read the file, you can't, there's no header, there's not enough columns in the data, then you have to test for those conditions. And that's where we'll get into several mocks to do that. It's important to only mock the smallest block of code possible. Often just a wrapper with one line of code. For example, if we wanted to test if a file was readable, it's the old TAC-R. Well, we don't want to have that in the actual. We can't do that in the mock environment because it's not reading any files or anything like that. What we do is we make it into a wrapper, and then when we've got that wrapper, that's what we mock. And how do you set up a mock? Mocks are stored in a file, and again, it's going to be part of that directory structure. The CSV manager mock in this case, and in fact, I'll get into that example right next, but the code itself is going to be setting up the mocks with, again, an array of arrays, where that we put the fully qualified name as the first parameter, and then whatever the tag is for the mock file. And okay, well, I'm going to go back to this guy here. Okay, so what we've got for the setup environment is we use Vim, and with Vim, I'm going to have the 3 vertical windows that are there, where we have, and I create them just through standard Vim commands, vnew, vnew. In the first one, we're going to have our test window. In our second window, the middle window, we're going to have our source, and then in the third window, we're going to have our mock file. And of course, each of these will be stored in their own tab. So of course, if you've got multiple modules that are going through, you'd have multiple tabs. Mock file is basically set up as a Perl hash entry. I've tried other things, but calling in the hash variable is probably the most flexible. I'm not running any code, so that whole thing about the RM TAC-R is eliminated because there's at no point will any of that code be run. And then in each window, as I've said here, the structure that was here, I think I don't have this slide anymore, but under your root directory, that CSV manager, there's going to be a t/test, and all this is created, and we're going to get into what this looks like in the next slides. But you've got a boilerplate for your test script, you've got a boilerplate for your PM sitting under the lib directory, and of course for your mocks. And then I basically open up another window, xterm or command, depending on what your environment is, do a dry run on it. Should be a clean run. There should be no errors. All right, so what does these different files look like? This is all as a result of that p start here macro. So with you giving it this is just the blank template that's there. The actual starting of the script would have replaced package template with your name of your module. But pretty much everything else is, wherever you see package template would be replaced with CSV Manager. The test template is invoked with the p-test macro. Because of the script that's at the beginning, you can get around that just by simply opening up that text file. rhconfig that I've talked about, that's what's being passed from the wrapper. Here you would add things like your CSV manager, your CSV file, so on and so on. Your startup, again, how many people here are familiar with test class? Okay, so what we have here is that the startup is run at the beginning of the script, and this is where I run that custom script load mocks. That basically pulls in what all the mock definitions are from your text file and opens up that module. And then setup, that's run before when you're running a unit test, you always instantiate a fresh object. There's no dependencies, so you should be able to instantiate just on its own. And there's a hash ref that gets passed to each one. So in that, you can have a base, so there's like nothing that's there, and then you can have one that runs the setup. Or you could have two different test scripts that are there that would have one of each. So that it's probably, when I think of it, it's probably better to have two separate test scripts, but for this model, that's what you have. The teardown is the opposite of the setup. It's run after the test method. And then there's shutdown. Shutdown runs at the end of the script, close out a log file, close a database, that type of thing. And then where the bulk of the work is going to be is in this bottom template boilerplate that's here, where you've got method, underbar, condition. So here's where I was going with that mix of snake case and camel case. Here you'd have, the next slide will be like a load CSV, and then with a condition of pass, or a condition of file name missing, or no header, or something that's descriptive. So when that error fails, you've got something that's right there that tells you that this part of the code failed for that very reason. Because again, when you're running through this, you're going to be running through it very quickly. Ooh, okay. So now this is the template for P package, and this is what a typical module is going to start out as. I put a lot of flexibility in there, as I put off on the top right there. It's far easier to burn than it is to build. So if you don't need all that stuff that's on these lines that are here, like a custom constructor, methods with delegation, all this other stuff, if you don't need that, delete it. Right? It's a quick fix. I've put in the standard methods that are here. That they're the setup, main, and teardown. They're just stubs. They don't do anything, but how many people are familiar with object-oriented code? Nice. Okay, so then what would happen in that case is that you have that top-level object, which is like that manager, and then on that it runs a setup on the first one. And of course that child process, it then runs setup on its children, and so on and so on and so on, all the way back. And if there's an error anywhere in that chain, it perks all the way back up to the wrapper, and the fail map will then say, hey, this is why it failed, and this is the error code that it's going to return. So it's important. The method that I use to run this, it's got the smarts to say, hey, if there's no setup, then don't fail, but it's always a good idea to have that. Some other standard some methods that you may or may not want. Infamous CRUD methods for the create, read, update, delete. Nothing else will serve as a reminder. Getters, setters, load, dump, ping pong type of functions where there's on, off, two-state, tri-state type of methods that are there. And again, if you want to change any of these templates, it's all just regular text files, so you can easily do that. And then what the mocks look like. Mocks are sitting in their own file. I often use here docs that are there and you can see here it's just regular hash strings that are there. So you can put whatever block of code that you want, as long as it's a scalar. So if you've got code refs, you can have array refs, hash refs, strings, whatever suits you for that particular test. The case I was talking about earlier, where you'd have your happy path, the conf pass string, where everything is now set up the way it should. Then you've got a bad baster. So it's basically a copy of the previous one, but I threw in a typo in the baster. So the code should fail on that, with some message to basically say that it's missing baster. And then there's another one now to say conf, it's missing the baster. So as it runs through all these unit tests, you're going to get the valid, and then each of the fails is also going to act like a valid. You do a dies okay on your test, and then that will that'll fail. It'll show up as what it was supposed to do. All right, so we now get into how do we get our first test to go through. Sorry, but can you guys see? Say yes. All right, very good. Thank you. So the first thing we're going to do is going to do that load CSV. This is going to be in our test script. All we do is we modify the code, we modify that test that's at the end, and all it does is it runs this method called load CSV, and it should return got CSV. How many people here are familiar with the actual test functions? Test more, test tap, all that kind of thing. Good. Because with test most, I think it had all these different conditions that were in it. So here we're just saying, hey, when I run load CSV, if it comes back, unless it comes back with got CSV, it's a fail. So when we run it the first time, of course it's going to fail. We haven't written load CSV yet. So that's cool. And when it does run, I run it in the debugger. How many people assertively run their code in the debugger? Really? Okay. All right. Well, again, one of the big methods about this is, especially if you're using it in Linux, you can restart your script, and by doing an upper R, boom, it comes right back. All your breakpoints are set. You do a C, and you go right back to where the code is. That's important because I put static breakpoints right in here so that once it gets past that first test, the code is going to stop there. So we see here in the first test that it failed. It came up with a stack message. It's definitely not what we wanted. So I go back to the test method, our CSV manager PM. I throw the method in there, and sure enough, all it does is it does a return CSV. And now when we run the code with the upper R and the C, it runs the way it should. And again, this is the debugger waiting on you. So basically at this point here, we found that there's no errors. Everything is running as it should. So of course, we need to blow this up. We need to add more features to it. So we want what the data is going to look like in the CSV. So I've put in the mock file, I've created this here doc, which is going to be as simple as a CSV file can be. 2 lines, 1 line for the header, 1 line for the data. And then we then go back to the module, to our test code, and then we say that, okay, when we run that method, load CSV, I want to return that data. And that's what that set mocks does. So that now, when we run load CSV with the got CSV, well, it kind of failed. It didn't come back with a wrong error message, but what was returned is the got CSV. It's testing for got CSV. Why is that? Because we didn't update the test script to show what that condition is. And in the next slide, that's what we do. We go through, we test, we change the load CSV, so now that it looks for that expression on that first line, we run the test, and now it's running clean. So of course, we need to keep building this up. We're break it down, build it up. Break it down, build it up. We're adding an attribute now to the object. I'm embedding now what the file name's going to be, make it somewhat flexible. Beef up the load CSV to handle some of these basic errors. We have a known good function, which is, in this case here, is going to be slurp into scalar, which all that was simply the slurp putting into a string. And again, I can't read the file. I have to actually read the mock. So what I've done is that I've wrapped it, basically. I've taken that slurp data, I slurp into scalar, put a wrapper function around it, and that's what I'm going to mock. Same thing with the TAC-R to make that file readable. And as you can see here from the code that we have that's here, I've taken, really should have got that pointer working. Slurp data, I'm telling it now that when that method is called, return that load CSV, which we had from the previous slide. when you see file underscore file readable, it always returns 1. And then we do some testing. We basically say that, okay, load CSV junk. It should come back now with the, because we've already set what the base file is, it's going to use that. So that's going to fail with this message that comes up, right? And it should have died like it did. And the message that's going to come is that there was no file defined with the junk.txt. Now we turn around and say, okay, we're going to use that file. We're going to set that attribute to junk.txt and now run the same script. And we basically say that all we're doing now is we're setting the mock so that it still returns that original mock data that's coming in, and it now comes through and it dies again with basically trying to say that there's no CSV data that's there. So we keep building up these test cases that are going back and forth. Okay, and we keep doing this now. We keep making that method more and more intense. Anything that we want to test is going to be just a single line, right? We want to test the most and mock the least. So then at this point here, this is why I was asking a lot of questions on the Git side. It's right for me. It's right now I just copy the source and I copy the wrappers and I copy anything that's in our common directory, dump that into a zip, and bring that and unpack that zip onto the production environment. Typically, all your development is done. If there's any code that changes on the production side, there shouldn't be, but if there was something that had a minor tweak, you're going to have to replicate that on dev. But quite frankly, if it goes on to prod, it should not change. So, yeah, my plan A is to somehow figure out how to get Git to work on that. Not to mention, once I got Git, then I've got a team solution. This is pretty much designed just for a solo developer. The other option was a compare and sync, where that it would sense that if there was changes that were done on dev and prod at the same time, it would at least tell you to say, hey, so you're not overwriting a file, and then you'd have to use something like git diff. gvim diff, I think, is the command when doing that. And if you get a chance, if you need to use diffs, that works like a champ. And then, yeah, you can go through with your code that is on there. All right, so before I open up for any kind of questions, I have questions to you. So from what you've seen of Rapid Apps right now, do you think that you would use more than 50% of what you've seen? Less than 10%? So that's like, yeah, I'm waiting for the booze. Okay. And how about somewhere between 10 and 50%? All right. All right, so would you be interested in seeing this in Python, JavaScript, PHP? Wow, okay, that's surprising. Perl, changing gears here completely. If from a presentation point of view or topics point of view, anybody here interested in the Gang of Four design patterns, and specifically how they would apply to Perl? Yeah, half. Okay, all right. All right, and then the next one was basically how I've got my environment set up at home. I've got set up on a Windows environment with VirtualBox doing a whole bunch of CentOS servers that are out there. Typically, it's like a mini data center. Each of the boxes have their own name. Each of the boxes have their own IP. DNS is set up. DNS was with a helper script, which will you can add a DNS parameter. You can allocate IP based on that. NTP is going to be the same conf file going across. SSH keys, where that you can go passwordless access between the servers, and then of course setting up Samba. People interested in that at all? All right. And how about using Docker for multiple environments in Perl? All right. All right, so then the last question is a career subscription service like lynda.com, Clean Coders. How many people are subscribed to something like that? Okay. How many people are thinking about it? All right. Okay, very nice. Well, then, at this point here, if there's any questions or comments, perfect. All these modules can be accessed from my Google Drive. Email me at the email that we've got there. And I'd love to hear what your opinions are. Again, we've got a lot of smart people in the room. I'm sure there's things that could be done better, more efficiently. If you've got suggestions, please let me know. Suggested reading. A lot of this stuff you're going to see coming off of Agile Samurai. Excellent introduction to Agile and that type of environment. And then Scrum. Scrum is what sold me on this by one of the actual godfathers of Scrum and Agile, Sutherland. Was anyhow, well worth the read, well worth the audio book if you are so inclined. Okay, on that level, any questions, comments? Everybody here is professional Agile now? All right, cool. Very good. Thank you very much, and enjoy the show.